Okay, so I have all of the equations written up for what each question, each part is asking me to find. Now, when it comes to position at t equals 3, the y is the easier one because they gave you the graph of y itself. So you're actually just looking at when x is 3, what is the y coordinate of that point? And the y coordinate is negative 1/2. To get the x coordinate, you have to realize what they gave you. They gave you that at time 0, your position was this x and this y. Now, I want to point out that the y coordinate matches the fact that on the graph, when t is equal to 0, y is equal to 1. Just want to point that out. The x coordinate is 5 when you're at time 0. To find the x coordinate at time 3, when you are given the x coordinate at time 5 and the derivative of x with respect to time, you're going to use your definite integral and the fundamental theorem of calculus. So if I integrate with a calculator, mind you, the dx dt function from the time that I know my x location to the time that I want to know my x location, then I need to also know at time 0, I'm starting at x equals 5. So I'm starting at 5 and adding the x displacement to that, and let your calculator roll that answer out. And that answer is 14.377. And that's worth 3 points. So I believe I just said 14.377. If I'm writing that wrong, please tell me. And now that's part A. Part B wants you to find the slope of the line tangent at t equals 3. So I wrote this up, but then I want to think about what that means with the information that I have. Because I'm dealing with vectors, then I want to look at dy dt over dx dt at time 3. When I go over to the graph for y, I want to remember that's the actual value of the function. Dy dt wants to know the slope of that graph at time 3. At time 3, I'm located here in the middle of a line that has a slope of 1/2. So dy dt is 1/2 at time 3. That is if I'm doing my math right. Up 1, right 2, yes. Then dx dt, you're given the formula for dx dt. So you're just going to, in your calculator, replace those t's with 3's, and a number pops out, and you'll write that number down here. So let's go to the answer that the calculator will give. So the calculator will give you this number when you plug 3 into your dx dt formula directly. And you can feel free to leave your answer right there and not have to simplify it any further. Next is part C. Part C is asking about speed. So you want to take a moment to think, what is the speed formula? It's Pythagorean theorem on the velocity vector. And at time 3 is specifically what I need to know. Now, the AP test loves to do this. Realize that you just found the two derivatives at 3. So the numbers that you just found up here and down here can be put into these spots, and then just let your calculator do the rest of it. So this is the 1/2, and the other one is the number that I just forgot, 9.956. And then that will wind up giving you that number. And basically, if the fourth digit is 5 or higher, there are 2 acceptable answers: the truncated version and the rounded up version. But you have to have 3 digits after the decimal point to get full credit, 3 or more digits after the decimal point. And lastly, total distance traveled. The total distance traveled is the integral of speed, but I am no longer dealing with speed at a particular time. I've got to keep it as a generic variable t. So I take a look at what I have, and I do have a calculator, luckily. I'm given the dx dt formula. So that's going to just pop right in there. For y prime, I've got to take a look at what is the slope while I am traveling from 0 to 2. And unfortunately, the slope changes. The slope is -2 from 0 to 1, but then the slope changes to being 0 between 1 and 2. That means you have to set up 2 separate integrals. You will do an integral from 0 to 1 and add to that an integral from 1 to 2. And the only thing that is going to be different, I'm just going to put dx dt here because that's the formula that's already given. The only difference is when I'm 0 to 1, my y prime is, I need to look again and make sure, -2. And then it was 0 here. From there, you'll throw it in your calculator and let a number beautifully walk out. And there you go.